My name is Jim Yannick. I'm with VMware. I'm an end-user computing architect. I'm based in Minneapolis and very happy to be here at VMworld. All my sessions are today. This is number 2 of 4. I'll let my colleagues introduce themselves.
Thanks, Jim. I'm Michael Cooney. I'm part of the EMC Extreme I/O Solutions engineering team, lead solutions architect with responsibility for virtualized solutions, based out of Santa Clara, but the accent is Irish.
I thought you were Texan. Really? That's Irish?
It's pretty close.
Sounds Texan. Any Texans in the room? If I've offended you, I apologize. I'm Tristan Todd. I'm with the End User Computing Business Unit with VMware. I live in Portland, Oregon, and this is my first session of the day, so it's my warm-up.
All right, so our session today is Horizon Storage. Let's dive deep. So we're going to take you through a whole bunch of different things today. Just out of curiosity, Tristan and I have been doing a storage session at VMworld for the past few years. Who's been to our session before? Oh, we got groupies, Tristan. This is cool. So glad to have you back. Glad we were good enough for you to come back. So just a quick disclaimer slide here. This, obviously we may talk about futures, things may change. You've seen this slide already probably a dozen times. So you've probably seen this one too if you've been to an end user computing session, basically talking about Workspace Suite and end user mobility. So Horizon Desktop, Horizon Workspace, AirWatch Mobile, and content collaboration with Secure Content Locker, the ability to access all of that through Identity Manager, and of course everything running on world-class SDDC. Gartner has rated AirWatch very highly, and we're #1 for the last 5 years, and of course on IDC recently, this last year, we're very happy with this. VMware's surpassed competitors in that space as well, and for the desktop. So a lot of hard work, a lot of innovation over the last 7 years that I've been involved with this. So what we're talking about today, we're going to talk about some tips for storage. We've got kind of a top 10 list we're going to talk about. We're going to go into kind of nouveau storage, that's Tristan's phrase, kind of talk about where the state of storage is today, try to rationalize some of the categories of storage. We're going to talk virtual STAN, we're going to talk all-flash storage, and we're going to talk specifically some use case and some things regarding Extreme I/O as well. So first, this is our disclaimer slide. We kind of put this up all the time. We're going to use a lot of examples. Your mileage may vary. We may or may not talk about your favorite storage solution. Don't let it harsh your mellow. We're going to use some examples. So yeah. So first, Tristan and I are going to kind of tag team a little bit of a top 10 tip thing here. You got a microphone on you? Yeah, you do.
Yes,
great.
I do.
All right. Why don't I kick it off and we'll kind of go from there. So first, don't gamble, do an assessment. We used to say don't guess, don't use a Ouija board. What you want to do is kind of get an idea of what's going on in your physical environment, or if you already have a virtual environment and you're looking to make a change, do an assessment within that virtual environment. We partnered with the folks at Lakeside Software for the Systrack desktop assessment. That's up online. I'll show you here in a bit how you can get to that. But the beauty of this is it gives you some data, some real information. We're talking about storage today, so some of the screenshots and things are focused on IOPS and those sorts of things, but we're also gathering information about what applications are being used. You see that nice little pie chart there that shows what online storage people are using, maybe of interest to you, especially if the company doesn't allow that. This shows some IOPS. Now what I like about this, and it's a bit of an eye chart, especially for you in the back of the room, but what this does is take a look at applications. So we'll see, because we're running an agent on those end user desktops, we'll see what everybody's running. We're going to get a good look at those applications, and in this particular chart, show what the biggest IOPS users are. So you have an idea of where, which applications are really hitting storage hard, and just how hard they're hitting it. This is another look at IOPS. This is more based on a machine, so you'll know who your top talkers are. It helps sort of stratify your use cases, because certain user profiles are probably going to use more IOPS than other user profiles. And then, how do you get started? Well, you go online and you sign in for an account, put the agents on the desktops, run them for a period of time, and go in and take a look at the dashboards. absolutely free to be able to use that. It gives you a start. It's not all of what Lakeside Software does with SysTrack. We'll talk about some of that in a bit, but at least gives you a start for getting an assessment.
And what's that URL, Jim?
What's that?
What's that URL?
That URL is assessment.vmware.com.
Thank you.
Sure.
You guys like stoked for the ATT Park Party tonight? Really?
Apparently not.
Wow. Who's running the bases with me tonight at AT&T Park? Anyone? Like one dude in the back row. Seriously? Okay, 2, 3. Wow. Okay. So we always recommend that when you deploy end-user compute solutions from VMware, you don't rely on your service desk, your user community. You don't rely on tools that are designed for vSphere to monitor your environment and keep track of performance and user experience. We recommend you deploy some tools. Obviously, we'd like to recommend our own tools. vRealize Operations for View or for Horizon is a great one because it comes with pre-built dashboards that are focused on user experience metrics, things like PC over IP, round-trip latency, and packet loss, but also some very good storage metrics. But it's really easy to build custom metrics from the same registers you access in ESX Top. And you can build these really compelling, simple-to-use dashboards yourself on things like vDisk latency. So that when you get over 5 milliseconds of latency, you can actually change the color of the dashboard, maybe alert an activity, maybe trigger some kind of an SMP trap or something like that. Log Insight is one of my new favorite tools because I can take unstructured data from things like syslog. I can feed it from individual ESXi hosts, but I can also take Windows event logs and push it to vRealize and actually build custom dashboards in the same way. This tool is invaluable for troubleshooting. ESX Top is great, but you can actually forward those host logs to vRealize, and there is a pre-built vSphere content pack that actually will show you when you're experiencing disk latency. It'll actually highlight where the queuing is occurring. Lakeside SysTrack, obviously, if you've been in the Solutions Exchange, they have a big booth this year. They have a great product that's focused on end-user experience metrics. Deploy a tool, one of our tools, one of our partner tools, VM Turbo's got something. Deploy a tool so that you don't find out about performance problems by getting a call at 3 in the morning from an angry user. Liquidor Labs has a great tool. Our PSO resources use it all the time, and they've got very colorful dashboards. This right here is actually a content pack that they've developed for vRealize Operations Manager. It's big, it's colorful. Each of those colorful blocks changes when the metrics exceed your threshold of pain. So it's quite slick.
Hey, I will mention something just on the tools piece. We get calls a lot from customers who are in crisis, and it's, the sky's falling, the world's ending, there's locusts in the data center, and they don't have any of these tools in place to kind of take a look at some of that stuff, so they want to, come in and put the tool in. Something especially like vRealize or any of those other tools that we talked about kind of gather data over time. So in crisis mode, we might get some value out of it and be able to pinpoint what's going on, but you're going to get a lot more value if those tools are in place more at the beginning of your project than when you're in crisis. Yeah, go ahead.
All right, so this is one of my pet peeves. Who here has gone to the Solutions Exchange and seen hero numbers about IOPS on storage arrays? Anyone? And those were back-end numbers, right? Back-end storage IOPS. We can push like 2 million IOPS on our array, buy 4 today. Anybody heard that? Anybody gotten that sell? All right, rock on. If you fixate on IOPS though, you fixate on back-end throughput numbers like IOPS, just realize that you're missing, you might buy a Lamborghini, but you're missing the roof racks and the trailer that you're pulling, which are the entire round-trip latency. So the rest of the queuing occurs, we're fixated on guest average, right? Because our users are interacting with a virtual machine. Guest average is critical. And most of the latency queuing problems can happen actually at the HBA or the host level. If the queuing is occurring at the kernel level, update your LinkedIn profile and go to an environment where you don't have contention at the host level. But realize that the back-end, the back-end performance numbers, that's only one part of the puzzle, all right? That hero number on the back-end array is great, but make sure you know what you can actually service at the front end, all the way to the vDisk. So the vDisk latency is the number. That's the metric that matters most. No amount of billions of IOPS or millions of IOPS are going to satisfy your users. It's all about the virtual disk latency. Trust me on that.
So the new expectations, right? What are users looking for these days? Okay, so what you're comparing your user experience to is somebody with an all-flash device. How many of you have tablets or phones here? Oh, every hand should be up, right? Any spinning disk in any of those devices? No. So you're used to a very quick user response, and that's what your users are expecting. I was talking to somebody yesterday or earlier in the week, and they were talking about an issue they were having where they were trying to do some operation, and it was a repetitive operation that all their users do, and there's a 1 or 2 second pause. I don't mind it much, but the users don't seem to like it. And I said, I would hate that. I'm a little too impatient for that. So, we don't want this. We don't want users waiting. We want fast performance, and you have to design that in there, and that has to be your end-all, be-all goal when you're doing virtual desktop or virtual applications. It needs to snap. It needs to pop. The users need to get their response quickly because they're going to hate it if not. I was talking to another customer yesterday at lunch, and they talked about how when they rolled out, and they did a lot of work for speed at the beginning. They were using local Fusion IO cards in their server back when they did this a couple of years ago, and their response was so good, they couldn't get stuff deployed fast enough to meet the demand.
Jim, you don't know what's going on behind you. This is the slowest hourglass
I know.
and spinning umbrella
It's actually
ever.
On purpose, actually on purpose.
Nice work.
Yeah. So use cases, understanding your use case. We talk a lot about that phrase, a use case. You really do need to understand it because you might think it looks like this, everything looks the same, but in reality, your users are chaotic, right? There's all kinds of things going on that you may or may not know about in their environments. And
Is this what entropy means?
and
Entropy? Is that the word?
Definitely entropy. I've been in so many customers where, yeah, we rolled the desktops out, but we didn't realize that they were doing X, Y, and Z. Did you go talk to them? No. Why would we talk to them? So understanding everything that's going on, understanding, hey, are they plugging in USB devices? Do they need client drive redirection? I know it's kind of ABC, but so many people miss it that it's worth mentioning.
All right, so I don't even know what's cut into the hood of that Honda Civic.
It's awesomely cool looking, though.
It makes it go fast, and I guess you can cook hot dogs on the hood of your car. Anyway, so what can software do, right? If you buy a slow car and then you bolt on some software like a turbocharger, like aftermarket chip. Has anybody chipped their Civic? Nobody?
Nobody's
Wow.
always willing to admit it anyway.
Does anybody know what chipping your Civic is? All right, just nobody's taking the risk. All right, so you can take a risk and actually do things in software. You can do things in our software, or you can implement a software solution from a partner. Has anyone implemented a software turbocharger like View Storage Accelerator, anything like that? Is anybody actually using one of those software tools in production? Few? Cool. So each of these things, by the way, don't read this whole slide. You can take a picture of it, but you're going to get these slides after the session. So I'll pick on View Storage Accelerator. When I first saw this feature, I was wildly impressed because it is a safety net for read bursts. If you expect a read storm during a recompose or maybe a Monday morning login storm, this will save you. However, the first time you go to recompose a link clone pool, you realize that your recompose time tripled or quadrupled in duration because you have more storage objects in flight. So the benefit you get in protecting you from read storms is awesome. It's very palpable. It's very real. However, the risk is that your recompose times are slower. So if your use case is in healthcare, where you only have like a 4-hour window for 2,000 desktops, the VSA may not be a good thing for you to implement in software. So kind of like putting a turbocharger on your Civic with a big blower, there's a risk, right? Fire, Neighbors might not like the noise, might smell, I don't know. Anyway, so I just listed, we kind of came up with a matrix and said, here's all of the things, vvolume, storage IO controls, that you can do in software to help with storage, but there's pros and cons.
Yeah, sure.
So apparently I have a car thing going, really? Sorry, I was out of ideas. So the importance of tuning. Has anyone ever implemented VDI, maybe in a pilot, or you were in a hurry and you didn't tune your image? You didn't tune your Windows master image. Anybody ever do that? I did that. I still do that. But then, I think somebody just flipped me off, but anyway. No, he's like, I did. Anyway. Anyway, So we've got this free tool called the OS optimization tool, and it's a free tool. It's a fling. Does anybody know what a fling is? It's not like an Ashley Madison reference, truly. This is free software that our labs people and some of our engineers develop. We don't sell it. We give it to you for free. We don't support it, but when you're optimizing your image, a free tool to actually go out and assess your image and its readiness for VDI, and then go ahead and fix the problems is amazing. It's free. It supports Windows 7 and Windows 8 today. It'll support Windows 10 soon. Even if you don't change anything in your image, it'll give you a scorecard to tell you how you measure up against our best practices. The other thing you can do is you can tweak the standard template for VDI to meet your organizational requirements. So if you go ahead and want to tune your image, you can deselect some of the recommendations that we make. It's awesome. Did I mention it's free? Free is awesome. Anyway.
Hey, one thing on that, I'll just mention here to add to, that we've got that for now for Windows 7, Windows 8. I think the XP paper is still out there, but God help you if you're still putting XP out. And also Server 2008, Server 2012, if you're using those as a desktop. Windows 10 is coming, probably sometime in the first half. I don't know that there's a date around that yet, but I expect Performance Engineering will stick a blog article up in the next few weeks talking about some of the tuning they did there. There's a lot more things running in Windows 10, so you're gonna be some things going on there. So, formulas. So there are a lot of calculators and formulas out there. We've used some formulas before in the past. I'm not going to throw a formula up here for you today, but there's a lot of calculators out there you can go to. We're releasing one here. I think it already got announced here at VMworld. You should look at this as a super high-tech napkin, okay? Because it's only going to be as good as the numbers that get put into it. So the default numbers are going to be sort of rule of thumb numbers, and we'll talk about rule of thumbs and how awesome they are in a few minutes. And then if you stick numbers in, which most of them let you do, your numbers, those numbers you get back are only going to be as good as the number you put in. So, if you have numbers that you got because you had a seance, as opposed to numbers that you got from an assessment, that's kind of what you're going to get. Our professional services, our partners who are in the room here probably will never do a full design based on simply a simple calculation or rule of thumb numbers, and they really shouldn't. We really should do this based on factual numbers. So calculators are great to kind of get you in the ballpark and give you some ideas of what's going on, but don't use them for a design. Let's talk a little bit about space versus performance. This is kind of an old conversation, but it still applies. Space is becoming more of a big deal again, especially as people are using Allflash or even local flash, where they're not getting the goodness of dedupe and compression. You really do need to do the space calculations. It's pretty easy when you're doing full clones because you're dealing with a full clone. The VMDK is pretty obvious. It's a little trickier sometimes when you're dealing with link clones, especially if you're using things like the persistent disk, the disposable disk. Maybe you're doing SE sparse, and depending on how often you're recomposing, hopefully you're recomposing. I've had customers who just put out their link clones and never recompose. Not a very good idea. That's going to hurt you performance-wise over time. Whether or not you're using View Storage Accelerator. Tristan already mentioned that. Another downside of that View Storage Accelerator, he kind of alluded to it by saying there's a lot of storage objects, takes up more space. And then memory reservations can help too. I mean, you can claw back some disk space by putting memory reservations in place, but that puts you kind of in a box on your host a little bit.
Does anyone actually, as a best practice, actually set a VRAM reservation on their linked clones or their full clones to reclaim some capacity? Has it been a good thing? Yeah. Especially if you don't reach a contentious state with memory and you don't overload your host. Cool. Nice.
And we've always spent a lot of time talking about do IOPS calculations, except when it really doesn't matter that much because the array can give you so many IOPS or the storage you're using can give you so many IOPS that's never going to be your bottleneck. We've kind of moved the bottleneck cheese back to the CPU. But potentially a worthwhile discussion, especially if you're negotiating a treaty with your storage team about hosting your desktops on their arrays. You might want to have some ideas around IOPS and what the impact's going to be. And then there's all sorts of other things that impact it, right? The use of View Storage Accelerator, what your array type is, whether you're using cache or not using cache. There's a lot of pieces in here. We're not going to spend a lot of time on that, but just to give you some examples of where performance impacts can come into play. I'll just talk through the rules of thumb.
So,
yeah. This is a rule of thumb chart that's actually in a publication that we have that's floating around. Okay, it's a set of numbers for users. They can be dangerous, they can be confusing, they can be downright wrong depending on your use case. It may not apply. Your mileage may vary. They're average numbers. Another thing that people don't think about is the read-write mix. If you got a very write-heavy workload and you're using RAID, you've got a write penalty in place. It's going to be a lot more IOPS, especially if you're using RAID 5 or RAID 6.
Yeah, I'll pick on a few of the storage partners in the room. There's a few. I won't call them out. I'll keep their anonymity. But how many of you have seen like a hero number on IOPS that doesn't say whether they support read or write IOPS? They just say 40 gajillion IOPS, right? If you don't know the ratio of the workloads and you don't know whether that's read-write, I mean, you really have to ask that question. It's a key thing. Oh, yeah. There you go.
And then there's the whole concept, again, average numbers. There's bursts, right? There's boots, there's provisioning. If you're provisioning during the middle of the day because you have to, because of some issue, that's going to come into play. Moon cycles, chicken bones. I mean, there's all sorts of things that can affect this, right?
Seriously? Lunar cycles?
Chicken bones.
That's what you came up with?
Lunar cycles. That's
wow.
And really, what I mean by lunar cycles is you're going to have monthly things that are going on. Users are going to be doing processing that could really impact read and write.
Like month-end reporting that
exactly
about the moon?
So. Average numbers, likely failure. Or do you want me? I can
I'll talk.
Okay.
I'm responsible for
yeah,
this.
It's your slide.
All right, so we recommend you choose a good storage platform. Right? Everybody knows the definition of a good storage platform, right? No? I don't know. So this is what if you ask me, if you corner me and say, Tristan, what's your favorite storage platform for EUC? I'll give you this. All right? It's a great time to be a customer. It's a great time to be shopping for storage solutions because there's so many cool ones out there. It's a bad time to be choosing storage solutions because there's so many cool ones out there. Some of these are startups. Some of these have just exited stealth. Some of them are shipping product. Really? A yak?
It's a nice yak.
So when you work at VMware, sometimes people slip a little something in to your deck, just without you knowing it. So thanks. Well done. Good work. I'm sorry?
So I actually put that in as a shout out to John Dodge, who was a colleague of ours who we lost unexpectedly this year. So that's my little tribute to John.
That's his avatar. If you've ever met John or saw his presentation, he's a brilliant guy. We do miss him. So I guess I'll start talking about Nouveau storage solutions.
Yeah, we'll just kind of,
since I'm going to repeat the slide anyway. So there's some great solutions out there in the Solutions Exchange. Most storage vendors, James Yu from TED Giles here, he'll tell you that VMworld is actually one of the premier storage conferences in the world today. It's a virtualization conference, but it's all about storage. There's some great technologies out there.
So let me just throw something in on the big slide of logos. Look, the important thing and the only important thing is you need to be able to deliver the performance that we talked about earlier to your users. There are a lot of storage solutions that can get you there. There are a lot that maybe won't get you there depending on your use case. And understanding all of the pieces that go into choosing storage is really going to be the important thing here, and having that data to base that on.
Yeah, I think VDI and EUC projects in general are a great opportunity to take a risk with storage, to break free from kind of a pedestrian, we always buy the same storage from this partner. It's a great time to take a risk and do something different. But you have to pay attention to all of these things. You have to pay attention to things like, is it easy to manage? Is it a storage vendor with a great support hotline? Reasonable to operate? Does it scale? All of these things, each of them is kind of specific to an organization. What Jim and I have done is we've come up with this acronym called SPAMS. I didn't put an S on the can. I could have photoshopped it. But the idea is that over on the left there, if you look at scalability, performance, availability, manageability, and simplicity, and then you categorize all the different storage platforms or types, you can kind of discern in a matrix like which of these types of storage is stronger. And you could even add some more letters to SPAMs depending on what your requirements are. But what we think is that for end user compute, virtual SAN and all-flash arrays are really kind of where it's at. They deliver the best performance for the price. They're the easiest to manage. They have the best integration. Certainly, Virtual SAN has great integration attributes with vSphere. It's all managed from within vSphere. From a scalability standpoint, realize that vSAN, as you scale compute, you're scaling storage, so it's a bit of a risk. So this is a bit of an eye chart. I want you to take this with you and maybe kind of assess it under your own organizational terms. But we really think that you should always look at storage and look at these 5 key attributes. Okay. So I think Jim wants to talk about Virtual SAN.
And I'm going to ask a quick trivia question. Can anybody tell me what state spam is made in? No, that's the answer to my second question. Thank you very much. It's made in Minnesota, in Austin, Minnesota, not far from where I live, but the biggest consumer of spam, Hawaii by far. Okay, and I got paid by Hormel for that little ad, so. So Virtual SAN. Anybody heard of Virtual SAN? That's a joke. Yeah, I know. So basically, Virtual SAN 6 and Virtual SAN 6.1 will be coming fairly soon, so I'm talking about some current features here. We support hybrid and all-flash, and I'll show you what that means in a minute. Obviously built into the hypervisor. If you're a customer who has Horizon Advanced or Horizon Enterprise, you get Virtual SAN for your desktops as part of that package. So if you're already in those licensing tiers, it makes sense to at least take a look at this as a storage option for you. We can scale out pretty far, right now up to 64 nodes in a single cluster. Generally, we don't scale out desktop clusters that big, so this actually will scale out farther than a desktop cluster typically will, because you're looking for 100 to 150 desktops on a host, and we're looking at for our standard pod and block architecture, probably no more than 2,000 desktops in a block, and that would kind of be the boundaries of a cluster for you. Some of the features with Virtual SAN 6, I'm just going to build that out. Obviously, all-flash storage is an option here, so we can go with a tiered layer, and I'll show you that on the next slide, where it's a flash cache and spinning disk for the actual storage, or a tiered setup where both the cache layer and the storage layer are all flash, and obviously we're going to get far more performance out of that. Really good performance. You'll notice the hero number on there, 200 desktops per host, and Tristan put a bunch of stars on there. We have reference architecture published with those kind of numbers with fairly light workloads. Your mileage is going to vary. We kind of think it's probably in the 120 to 160 desktop, but again, those numbers are going to vary. Another big thing we did with Virtual SAN 6 is we upped the number of components per host, which actually lets us put more desktops on the host, which is why we can go past what our initial guidance was to say 100 desktops per host up to 200 desktops per host. And another thing with Virtual SAN, you can build your own. You can go out on the HCL and I want this server and this controller and these disks and build your own, but we have this concept of a ready node. So the various OEMs have put together Virtual SAN ready nodes that have all the pieces and parts. These are some of the scales here. I'm not going to go through this line by line. You'll have the slides. But you can see you're going to get far more capacity and far more capability on your on the all-flash side just because of the basis of using all-flash. So a lot more IOPS, a lot more throughput. Okay. Michael, I'm going to turn it over to you.
Thank you, Jim. Okay, so Horizon View and all-flash. So I'm not here to essentially sell you any solution, because if you have a Horizon View requirement of a certain scale, then you're probably already considering all-flash as it's the right answer in the majority of use cases, okay? So in terms of all-flash, really I want to just give you kind of an overview in terms of how you should consider the array and how you should just maximize the capabilities of a product that you either purchased and it's in your data center or something that you may look to in the future, okay? Now, as a disclaimer, if you haven't seen the shirt, yeah, I'm an EMCer, okay? So the examples in this deck will be Extreme IO because it's what I use on a daily basis and, it's what pays the bills, okay? But what I should talk about will be storage agnostic and should be applicable to any use case. Okay, so what you see here on the screen It's a typical view solution, okay? So we have a pool of desktops, we have our virtualized servers, we have our network on the top, we have hosting infrastructure all sitting on enterprise shared storage. Okay, and typically for most of you in the room, I'm going to guess it's something that you design, deploy, manage on a daily basis. For us guys, it's something we actually break down and build back up on a periodic basis also. But the main point here is what you're looking at is essentially a game of performance, kind of whack-a-mole. You look for the bottleneck, you find the bottleneck, and you upgrade that component. So Allflash for Horizon View, essentially it's, you know, you've seen the performance bottleneck in terms of we need more IOPS, we need more dense capacity. Okay, let's put Allflash in there, and we've just moved the problem back to the compute layer. You know, eventually that'll re-up, and we'll be back to a storage problem in the future. But for Allflash, essentially it's, you know, the first thing that comes to mind is performance. And, you know, like Tristan and Jim talked about, we talk about hero numbers, and you see them on the screen. People will, you know, show you numbers like incredible bandwidth, and they will show you, you know, super high IOPS, minimal response times. Although in this case, the response times are pretty representative of an average workload for those 1,000 desktops. And we have response times pretty much in like about the 400 or 500 microsecond range.
And Mike,
but if you start thinking as a VMware admin and what the desktops or the hosts are going to realize, you know, you're going to have to account for round time, about 2-3 times what you have there.
Mike, what are those weird symbols next to the numbers on the right under latency?
These ones?
Yeah. Is that like some kind of Greek lettering? I'm not so smart. What is that?
Gold star for Tristan. It's microseconds. Okay, so that is a 1,000th of a second.
Nice. And the dark versus light blue, is that reads versus writes?
Exactly right. So obviously reads will generally be lower response time than writes, and you can see the differences associated with both there. But actually, just staying on this tab for a minute, and maybe Tristan or Jim, I'm going to put a question out to the audience, and if anybody can tell me why they would not buy an all-flash array based upon the numbers here on the screen, if you can point out the exact reason why we shouldn't buy an all-flash based on these hero numbers, I think there will be a gold star for the audience somewhere. Anybody want to take a stab? Well, you're nearly there, but can anybody? Well, okay, so I'll go there. I think that's about close to. But if we look on the left, we see 44 gigs a second. Okay, that's a ridiculous number. Okay, it's you know, think about the connectivity options. Okay, so let's say we're using 10 gig or 8 gig. How many links do you need to drive that type of traffic? It's not representative of what you're going to, you know, see on your host side. What you're looking at is a VAI Xcopy operation, so offload from the server on array, block copy. Okay. Now it's representative of what the array can do because it's in memory, but you know, you need to. If somebody starts showing you numbers like this for Allflash, ask the questions, understand where they come from. You know, fully consider any product like that that you're going to put in your data center. So I think was who gave the answer here? I think it was in the. Well, I think we can be honest. So put your hand up if you got the right answer. But anyway, so performance. It's why you buy Allflash in the first place. But you know, it's not all you get when you buy Allflash. And this is essentially a question I ask anybody who comes into my lab or into my space. You know, if somebody wants to sell me a solution or somebody wants me to, you know, integrate something, well, I ask, what problem are you solving and why do you do it better than the other guy? Okay? So if we can't get past that sentence in the first place, then there is no discussion. Okay? So what problem are you solving with Flash? Okay? So that's pretty slow, but okay, so Flash goes faster. You know? So ironic. I think that's the right use of ironic. But okay, so use Flash, go faster, but if that's all you're getting out of it, then you're probably paying too much for an all-flash array. You really want to understand why it can make your workload smarter, okay? Smarter at the speed of Snail. But okay, so Flash has certain capabilities, but really all it is in terms of an all-flash array is an enabler, okay? It's the engine. It allows you to go a certain speed, but it does not offer it is not the basis for the capabilities that you buy in an all-flash array. Okay, most all-flash arrays and the majority out there, whether they're EMC or somebody else, should be intelligent and data aware. Okay, so you start putting the elements together, you end up with an architecture which delivers business value or efficiencies that you can realize for your own solutions. Okay? So typically, these are the feature sets. So this is an EMC Extreme I/O slide, but most of these features will be available. But the top three are really what I kind of want to touch on. So we have always-on tin provisioning, okay, and the next two we have inline deduplication and compression, okay. So this means that when you write in your VM or in your hosted desktop, from the hypervisor level, there's a write, but onto the array, it's only compressed, unique data which is written to flash. Okay, it makes things, it can get complicated. Okay, so that's, I tried to figure out a way to explain that here today, and I keep on coming up with this picture, the Russian doll. It's layers within layers. Okay, and then I said, okay, well, how am I going to explain this? Because I don't want to be here for 10 minutes and just talking in circles. So I said, okay, let's get a graphic, and this is my high-tech version of a volume which has been offered up to the ESX layers. Okay, so this is a provisioned storage volume, and within that volume, again, these are like the slowest graphics I've ever seen, so I'm just going to click through them. But so at the top layer, we have what's provisioned, what's offered up to ESX in terms of the volume size. The next layer down, the used layer. Okay, again, what's being used at the hypervisor level. Okay, or at that layer. Now we need to come down one more, and we figure out what's being consumed at the array. And because of our deduplication and compression, we need to go down one more layer to figure out what's actually being physically written on the array. Okay? So when you start putting those levels together, it actually impacts your sizing calculations for your view environment significantly. Okay? So again, this is not the most high-tech slide, so we'll just try this one more time. Okay? So we push that guy out to the right, and we have our volume, which we offer up, the ESX. Within that volume, we have a number of capacity considerations. So again, this is about as high-tech as I get with PowerPoint. So if it works, great. If it doesn't, I tried. Okay? But so we have a tin provision volume. Within there, we have the use capacity, which is on the array. So again, you give an OS 30 gigs, he uses 20, you get it. So within that, we have other considerations. Okay? So the orange, and apologies if anybody is colorblind, I'm pointing at the top left volume there. Okay, so the orange one is what's used at the hypervisor. Below that, most modern all-flash arrays, and any flash product, to be honest, whether it's PCI or all-flash, shouldn't write zeros. It's a pointless operation because most flash is essentially kind of a metadata management scheme. Okay, so it's a combination of indirection schemes and metadata management. Those are essentially what unlocks the value of the flash underneath. Okay, so a flash is essentially, it's an engine. It allows you to move as the car, but if we consider the driver as the OS, or probably more of a relevant kind of theme might be driverless cars. So if we start thinking what Google and Uber are doing, they have a car, okay? But what they're building is an operating system that can take advantages of that engine and operates in the most efficient and intelligent way possible. So again, with Extreme I/O or with any all-flash array, you need to consider not just the flash, but the operating system above it and how it does what it should do. Okay, so with most flash, moving from orange to yellow back again, we shouldn't write zeros. So on the array, we should see the logically consumed. And then below that again, we have dedupe and compression, which means that you end up with a physical volume on the array, which is going to represent the provision at the hypervisor level. Okay, now, a lot of you in the audience are going to be VMware admins, and some of you will never ever consider understanding how the storage works. You send a mail to your storage guy, you say, I want such a capacity, many IOPS, and that's it. I'm of the belief that, the two departments need to talk a whole lot more. As in VMware the VMware guy needs to get intelligent about how the storage operates, the storage needs to get intelligent about, how that storage is actually being utilized and deliver the proper solution. It needs to be a more holistic approach, I think, is the right way of putting it.
So Mike, quick question. So obviously you're from Extreme I/O, but does this pattern play out with other all-flash platforms that have compression and deduplication technologies built in? Is the same kind of concept applied to the other guys? Not to put you on the spot, but
no. It's fine. It's a valid question. Sure. It should do is the answer. Again, it's always the same engineering answer. You'll say it depends. Okay, but the real answer here is that these are capabilities that are available with Extreme.io, but with Allflash that's built around indirection and metadata management, are capabilities that you should be asking your storage vendor, whether that's EMC or another. You should be asking what capabilities they are, what value add they give to my solution, what do I need to take full advantage of the array that I'm purchasing.
Okay, cool, thanks.
Okay, so this slide, this is my kind of my flow through. So again, we're talking physical to virtual or tin provisioned capacity size, but this is my mandatory marketing slide. So for the marketing guys in the room, this keeps them happy, I believe. But it does 2 points for me, and if I can kind of come over here and maybe point them out. That first number, 10-to-1 reduction in capacity. So that's 10-to-1 physical to logically available capacity, okay, or logically consumed capacity. So for, you know, and another thing, if you buy storage, you read the small print. The small print on this one is 10-to-1 reduction in capacity for full clones. Full clones, obviously there's a high level of dedupability, okay, so you take that into account. For linked clones, you're going to be down a lot lower. It's going to be like somewhere around 3-to-1. You know, and you start, if you enjoy levels of compression or dedupe or, you know, reduction in data size, you end up with, you know, these type of crazy numbers down the bottom, which is 3,500 desktops per brick. Again, read the small print. This is linked clones. If we're using full clones, that number will be less. You know, generally I would recommend probably in about 2,000, which is about the scale where Allflash really makes a whole lot of sense in terms of costing and efficiency of the solution. But again, hopefully you take those points from there and you can build your solution. You don't take those numbers literally. Ask how they were you know, reached, understand the calculations, and then apply it to your own environment. But, you know, I was kind of hoping that the majority of you in the audience wouldn't end up like this after, but I've tried my best to, you know, explain and maybe, you know, help you kind of use Allflash. I wouldn't say better, but I would say more efficient if possible. And maybe some of the points that, you know, you'll kind of walk away from here with today is that Flash storage is not just performance. If you want, you know, plain performance from Flash, okay, well, you probably shouldn't be paying for an intelligent storage array which uses Flash. You should just go with a cheaper DAS solution. Spec sheets, you know, like Jim and Tristan talked about, you will see hero numbers, okay? Understand that those hero numbers are hero numbers, they're marketing. So understand their capabilities, but verify them in your own environment, because there is nothing more important than your data center, your workload, and your operations, you know, as in build a solution based upon that, not on somebody's spec sheet. I wouldn't go into a car dealership and buy something on a 0 to 60 time off a piece of paper. I'll test drive it. Okay, so maybe that last point here on the screen, if you think about it and you kind of go, just take the first word and it's consistent, accurate behavior of real world workloads. That's what you want to figure out. That's what you want to verify in your environment. Make sure that you pick the right solution for that. In terms of validation, generally I use a View Planner or Login VSI. Okay, so what you see on the screen here is, excuse me, what you see here on the screen is 2,500, 3,000 and 3,500 full clone desktops running on a single brick. So that's a 6U of rack space. Okay, what you want is you want predictable, consistent, acceptable behavior, which I think we can see here on the screen. Now, this doesn't mean that I'm going to recommend anybody to run 3,500 full clone desktops on a brick, because you have other considerations outside of everyday normal workload. But in your environment, you test, you validate, you verify, and you're next on the line. Make the right choice. And for those that actually do have Allflash in their house, again, understanding these behaviors, these capabilities, the fact that it's an indirection-orientated metadata management. I'm glad I said all that. But if you have it, okay, if you have Allflash, you follow the house rules, okay? Apply all best practices from both VMware and your storage vendor, okay? They haven't been put there for fun, and they will make your storage environment and your virtualized environment play better together, okay? And anybody who has Allflash, if this is your first time seeing the word space reclamation, I would highly recommend that you write down those two words, space reclamation of Allflash for VMware. Okay? This is probably the most important aspect of managing Allflash arrays in a virtualized environment. And if the VMware admin and the storage admin are not talking nicely to each other, this is an area that's often overlooked. This will highly impact the behavior of your storage over time. Okay, so take note of that word, Google it. Actually, my CTO, Itzik Reich, he's a big believer in this particular topic, so you'll find a lot online about this. And I think that's pretty much where I'm going to leave it, unless you guys want to get back up here.
Just for a minute. So, thanks, Mike. So this session, we've always kind of brought a whole bunch of different things within this session, and hopefully you picked up a few tips today. We want to give time for questions. We've built in plenty of time for questions because we always get a lot of questions. Last year, I had to literally run out of this session to make it to the airport. Fortunately, we don't have to do that this year. We've got swag for questions. We appreciate you guys coming. There is a survey, and if you like the session, you'd like to see more like this, go ahead and fill out the survey and let them know how much you liked it. If you didn't like it, just keep that on the down low. We're okay with that. But the mics are open in the aisles if you want to ask questions. We still got plenty of time.
With virtual desktop infrastructure on shared storage, do you have a preference, or are there any performance benefits to NFS over iSCSI or opposite?
That's a really great question.
That's a classic. NFS or block, is that the question? Which is better for EUC? I don't know. I used to love NFS because I could create a data store, massive data store with lots of virtual machine objects, and I could make it bigger dynamically, and I could fit a lot of virtual machines, a lot more on that data store than I could with a classic fiber channel LUN or iSCSI LUN. But the times are changing now. On Extreme IO, for instance, just to pick on them, I've put like 2,000 desktops on a single LUN, and it was fine. And I know that we publish the maximums. Anybody know what the maximum number of VCA or VAAI virtual machines on a LUN via a support matrix? Does anybody know that number? No.
No. Do I get a prize?
It's not 128. We're talking VAAI. Nope. Who said 140? He gets a prize. He guessed like 3 times though. He was like 116, 128, 140. Yes, sir.
Does VMware have a recommendation for latency for storage? I mean, I know the simple answer is what's good enough, but I'm trying to sell my CIO on what an appropriate number is that we can negotiate with our storage team to deliver.
Okay. It's really easy. You let the latency increase until users scream, and then dial it back 1 notch.
Yeah,
That's it. The answer is, we consider latency in the server world as 30 milliseconds, right? Our storage I/O controls defaults at 30 milliseconds of latency before it actually makes a recommendation or makes a move. In reality, users start to scream, and it's noticeable when latency is 5 milliseconds, reads or writes. So my recommendation is shoot for 5 milliseconds, sub 5 millisecond latency for reads and writes, and you'll be safe. We don't publish that. But I'm telling you, in the professional services world, less than 5 milliseconds is a good target.
And I'll just tell you a quick story from a customer. I got called in, it's a number of years ago. Every Tuesday morning at 9 o'clock, their latency would crack up to like 50, 60 milliseconds. Nobody would be able to use their desktops. It would last for about a half an hour, and then it would drop down. We finally isolated that to some application updates that were already happening all the time. But when I walked in the door, the bigger problem was their steady state burn of latency was 12 milliseconds. I'm like, this is kind of high, guys. Do your desktops perform well? Well, users complain, but we're okay with it.
Yeah. I know that well. Thank you.
That was a great question. Yes, sir.
Hey, so we use persona management. Have you seen any? Obviously, it depends on how much a user's reading and writing to their user profile. But would you recommend going all flash for that storage as well, or? I mean, have there been any like benchmarks in terms of?
Wow. Wow. That might be the question of the day. Yeah, I think he might be the one.
That could be the question.
Seriously, I think he gets the.
Yeah. I think that's the one.
That's the one.
That's the question.
You just want a GoPro. I'm sorry for the guys standing in line behind you. That is a very tough question to give you an answer on. You already answered the question because you said it depends, right? If you're using something like our user environment management technology that we bought last year from Amidio, it is filer based. And I would say that a top quality filer something from a Veer or Isilon or one of our other great filer partners, if it's well architected, will serve you well. But it's so dependent on the persona management tool in use. Typically, we kind of treat persona information, user data as a second-class citizen, kind of a tier 1, maybe a tier 2. However, depending on the use case, persona, especially as it applies to login times, could be of key importance, and you've got to use tier 0 or tier 1 because the initial login experience has to be swift. So I would say that, I mean, it depends.
Don't stick it on that creaky CIF share that's been around for the last 8 years and is already over provisioned. I actually have had this happen. You know, customers like, well, you know, View Persona is not performing very well, and they've got it on this really, really awful storage, and they just got too many users hitting it.
Yeah, we've definitely been guilty of that in the past. You know, we'll have, you know.
Here's where you don't put persona information on a virtual Windows server running as a file server. Okay, don't do that unless you've got 4 users.
Thank you.
I guess this is kind of for you, Mike, since you were doing a lot of testing with the Extreme I/O, which we're probably going to buy next week when we get back. Is when you were doing your testing, how did you carve up your data stores? Because that's a real concern for me when I finally get this in place. What's the best practice, or what did you find for when you were actually putting your your desktops out there? Did you carve it up differently than you would like in a tiered storage environment? Were you finding like what was your maximum you were putting on a data store with? Because I'm not sure how to break that up. I usually would break it up differently when I have different standards of storage, but since I'm all flash, I'm not really sure how many I should be dumping into.
I wish we had a second GoPro, but
Wow.
it's an
I'll take a
excellent
flash
question.
drive.
No, that is really an excellent question. Because first of all, the limit that Tristan talked about, if we're talking in link clones and we have the VAI-enabled data stores, then VMware best practices are 144. For non-VAI, we have 128, which was the first number, and that was also halfway correct. I don't like that number. And in my solutions, I've done desktop, you know, as in 144 desktops per data store.
Mm-hmm.
I've also done over 1,000. I've done 2,000.
Because then it becomes like a
Just-
VMware
it's the
limitation, but where does that maximum really hit?
but I haven't got a full understanding of why that limit is there, so I revert back to VMware best practices, and I would say 144. Now, for full clones, it's different. And the complexities that you have in a tiered solution aren't there for Allflash. Allflash is supposed to be completely and equally distributed across all available storage controllers and storage. So you should be able to realize the performance capacity of all controllers within your storage solution at all time. So again, for full clones, I've done minimal numbers in the hundreds. I've also done 2,000 on a single data store.
We're doing link clones pretty much exclusively.
So
So link clones, I would say stick with VMware best
I
practices.
started with Extreme I/O before the EMC acquisition, and we did 2,000 desktops, and I first started with our support maximum, and then I said, well, what happens if I only do like 10 LUNs for 2,000? And then I said, well, what happens if I do 8? And then I dialed it back to 4, and then I did 2, and then I did 1. And I measured the performance across all of those test cases, and the results were all the same.
That's crazy.
So do you want to manage 10 objects or 1 object?
Yeah, well, I'm
But-
managing too many today, so
But
less is better.
when you call VMware GSS and say, yeah, I've got 2,000 desktops on a single LUN, they're probably going to say, what? Huh?
Because isn't there like a
Call
SCSI
me back,
reservation error?
call
or
me back
something?
when you sober up, is what they're going to say. So my advice is to work with whatever storage partner you work with and ask them what they think the safe number is, and then make sure that when you talk to GSS that you're not using a traditional VNX or a traditional old school array. You're using something that's all flash, low latency, because I think they'll give you a better support experience.
Okay. All right, thanks, guys.
But take a risk, seriously.
Oh, yeah. We'll try it.
I think this is the last question.
I think I'd add to that. Take a risk, but verify that your support contract will still be valid if you take that risk before you take the risk.
Yeah, Tristan Todd at VMware.com said it was okay. Note the date and time.
So
Sorry.
my question is more around the Extreme I/O. We've been considering buying one. We currently are using a 7-year-old storage array with View Storage Accelerator installed on it. So the question is, if you go with a solution like View Storage Accelerator, does that really negate the options for acceleration like View Storage Accelerator and some of those other products that are doing like write acceleration like Pernix Data? Not that's just something additional I had on my mind. So
It's interesting. I haven't actually put the two together yet, but you know, IOTA serviced from the array will be at all-flash, you know, expected latencies. Anything that's serviced at the VSA, it's going to be already there. You're going to have to ask yourself whether or not it's a cost-effective solution to put the two together. But if you figure that you're going to be trashing quite a lot in terms of the, you know, I guess the locality of access, then it might make sense. But to do that, you'd really want to do an analysis on a typical workload and, you know, the various kind of periods of activity during the day. So really, that is the ultimate it depends answer. But, you know, understanding your workload as in what the profile looks like, how it acts at different times of the day, how that data set has been accessed, then you can start seeing whether or not you want to pay the money for, you know, essentially 2 accelerators in your environment. You know, so again, I can't really answer that question without doing like a proper study on exactly how it would be used on the back end.
Okay.
But,
Thank you.
And I think, guys, if you have more questions, we'll hang around. So just come up and ask. Also, if you'd like a really nice pen, we got a bunch of them up here. Come on, get them. And posters. We got posters